Good morning, ladies and gentlemen. Thank you for being here in numbers for this first scientific conference for the Veolia Institute and the DEST. This is going to be a very interesting conference with Professor Yves Lévi. I'll give him the floor in a few seconds. A few words about these conferences. Why did we decide to organize them? As you might know, or as you will know, the Veolia Institute for a very long time has organized conferences with high-level experts to address the geopolitical, health, environmental issues. The objective is to shed some light on these issues, and for a while the Institute has decided to address more specifically a topic that is very interesting for Estelle Braclianoff and the management: environmental health. This is an increasingly important issue that concerns all businesses of the group. It's a wide-ranging issue, so how to address it and who can we talk to about it? So we talk with Séverine, with the DEST, with the Zveri, Gualine, Research Innovation. And we tried to see what were the issues to address and who we should invite. So the Institute will have a special issue of the Fact magazine on environmental health, and we thought we should start with a series of conferences to dig deeper in this issue. With the support of the DEST, we thought that the first person to invite would be Professor Yves Lévi. Does my microphone work? Oh, it is not connected, apparently. Sorry if you might have missed what I said earlier. So hello, everyone. I won't repeat what I've just said, but this is the reason why we're organizing those conferences. And so we now have Professor Yves Lévi with us because he is an expert in this on this topic. He is a chemist, professor emeritus in public health, environmental health at the Paris-Saclay University, and his work focuses on these issues. So what do we know? How do we assess the health and environmental risks tied to organic micropollutants present in waters, for example? Not only, but also the endocrine perturbators, drugs residues, illicit drugs, everything you find in the water, and that needs to be removed as much as possible. Without further ado, I'm going to give the floor to Felix Rebrac, who is going to talk about the sponsorship that started in 2019 between the Medical Academic Foundation and Veolia, different departments from Veolia, and then Professor Lévi will give us a presentation. He will be interviewed by Luc Mosseron, who is the environmental health expert from the DEST. You will then have an opportunity to ask him some questions, and later we'll be able to continue discussing because Professor Lévi is going to stay with us after the conference. There will be a cocktail, and you are all welcome to attend. It is just upstairs. We will be able to ask him more questions and have a drink. All of this content will then be available on the intranet website of the Institute, the presentations, the Q&A, once we've collected them. Because, just by way of conclusion, we wanted to really have a broad coverage. So everything that I'm saying is simultaneously interpreted into English. That way, people who do not speak French can still understand what's happening, and everything is going to be available on streaming, and it will be available on replay on all of our channels. Thank you very much, and Philippe, you have the floor. Thank you, Dina, for this introduction. I'm going to talk about the partnership with the Medicine Academy. It is a sponsorship program. The Academy was, have free reign. This was started in 2019 with Antoine Frérot. And beyond the DEST, Veolia Water France and SAP participated. The objective of this program was to work on the notion of exposure. We will talk about exposome. Yves is going to tell us what exposome is. So, being exposed to some compounds have an impact on our health. How does that work? Those are complex mechanisms. And since there are hundreds of thousands of molecules of compounds, we need to decide which one we should start with. We started this discussion, and the Medicine Academy Foundation worked on that. On the 3-year cycle, there were several debates that convened international experts, institutional organizations, NGOs, consumers, and also the public authorities. A lot of senators and MPs contributed to the discussion, and there was a final report or feedback at the National Assembly with the MP, chair of the Environmental Health, Ms. Violent, head of the Health and Environment Committee. So this sponsor enabled us to clarify what we know and what we don't know regarding those micropollutants, and it was also a way to identify some potential avenues of research on the microsome and on the transfer of those results toward the political sector, which is going to work on the regulation side. This is going to lead to a white paper, a public white paper, and a glossary by the end of the year. Yves is actively working on it with people from the Medicine Academy Foundation. I'm going to give him the floor, and he's going to give us a presentation on this topic. And Luc Mosqueron, our health environment expert, is going to ask him a few questions after this presentation. So please join me on stage, and thank you very much. Thank you, Dina. Thank you, Philippe. And thank you very much to Professor Lévi, who's accepted to attend this first conference from the Institute. The topic is environmental health, more specifically the chemical hazards and the impact on our health. Now, before actually talking about the chemical risks, there is one first question I would like to ask you. Could you please tell us what environmental health is? And could you tell us how this concept saw the light of day? Thank you. Good morning, everyone. Thank you for your invitation. Thank you, Dina. Thank you, Philippe, Sandrine, Luc. Now, how did this emerge? Now, we're talking about environmental health as something brand new, very innovative, but it's important to remember that back in Hippocrates' age, he said that houses or cities shouldn't be built where the environment was not healthy. So people very early on understood that it was important to have a healthy environment, not to get sick. And then there was different developments. And in France, the first public health structure was a city bureau in Le Havre. So the cities, even before there was a health ministry, the cities realized that they needed to manage the relationship between people and public health through urban systems. So it continued changing, etc., and we've made great progress since then. I'm going to define a few things about environmental health, just to set the scene, and then we'll continue our debate. Environmental health, well, the basic definition of health is, according to the World Health Organization, a state of complete physical, mental, and social well-being. Those are essential. So we're not only talking about physical diseases. We tend to overlook mental or psychological illnesses, but those three states need to be complete. Then public health, organized efforts of society for everybody's well-being. So it involves a health economy and everything that has to do with the economy. And within public health, you have environmental health. Now, environmental health focuses on all the impacts and hazards coming from the environment that have an impact on our health. At the bottom of the screen, you have the various areas that are relevant. There are quite a few of them. Now, what's essential in all of this is the fact that there are hazards, chemical, biological, and physical hazards in our environment, plural. There are exposures as well, because every day, round the clock, we are exposed wherever we are to hazards. Small, large, throughout our life, even when even before we are born. And then on the other side, you have risks. So what's important is to understand that there are genetic factors that we inherit from our parents that are going to lead to genetic diseases. We now have gene therapy, but it's still in the early days. The rest is epigenetics, so it's everything that's happening to us beyond genetics. And environmental health focuses on that more specifically. We have environmental linked issues, but it also comes from our life cycle, our education, our social background, etc. And then you have accidents, wars, etc. that leads to death or disabilities. And it is this node of components that have an impact on our health is very much focused on environment. So if we don't want to get sick, we need to remove the hazards. Easier said than done. Then we need to remove all exposures. And if there are no hazards and no exposures, there are no more risks. Now, that's the foundation of everything. And so the pillars that I can present now, I'm sure there are others, but based on all of this, we can come up with 4 pillars. First, you've got analytical advances. For the past 20 years, we've made great progress. Now we can assess very, very fine parts of contaminants in water, in the air, and you've got analytical experts that have a long list of products, because when you ask them a question, you ask them, is this dangerous? Is this hazardous? They say, well, I'm just a chemist. I'm not a toxicologist. I can't answer. Oh, okay. So we talk to the toxicologist, and the toxicologist says, well, look at the diversity of all those compounds. And this is the second pillar. We mean that there are many, many different compounds. When we talk about perfluorated, we are talking about more than 1,000 compounds for the perfluorinated. And for 15 years, we've discovered more and more. And then you have another issue, the fact that it is everywhere. There is an intercompartment. So we can say, oh, this is a water-related problem because we analyze a lot in the water, but it also has an impact on food, and we don't know as much. It also has an impact on the air, on the whole environment. So we mustn't work in silos. We mustn't and shouldn't work in silos. And the last pillar is One Health. So we realize nowadays, it sounds quite obvious, we realize that if us humans are ill, it might be because animals or the environment are ill. So if we protect the environmental, human and animals' health, or the environment and animals' health, we will also be protected. So in terms of analytical advances, I've put a little dot clouds on the top right. You have an example of analysis with thousands of tests. So in a glass of water or in some air, you've got all of this, and we now know it. Since we know it, unfortunately, we can't just ignore it, and we have to try to see whether it has a risk, if it is a risk for our health or not. The microorganism pathogens identification has improved. We also have pathogens monitoring, so we can identify where are the pathogens on which animals, etc. It's a way to detect risk for men and women. There are also physical hazards. We don't talk about it enough. There's temperature as well. And then there's epidemiological studies. There's a study of diseases among men and women. So this has made great progress as well. So we know more and more. And so about the chemical hazard mixtures, here they are, and there are more and more, and there will be more and more. Now, the main concern is for what's going to happen in the future. It's quite worrying because there are no borders, no limits, and just like climate change, chemical pressure is a global and anthropic pressure. As for the environment as a whole, obviously you are quite familiar with the topic, but it's important not to consider that it is our neighbor's problem. Your chimneys, your water treatment plants, all of this is part of an ecosystem, and there are hazards that are going to be a bigger and bigger concern. And the last thing, one last thing. One Health, you might have heard about this problem, One Health, this issue. In France, vets addressed that. They said, we're going to talk about the zoonotic diseases, so the viruses and bacteria that travel through animals. But it's not only about vets, it's not only about animals. It's animals, the environment, including vegetal and or the flora, and humans. It is this the cohesion between those three factors that mean that if we break one, we break the others. And so it sounds like a no-brainer, but since this concept has been developed, or generally speaking, we are surfing on this wave. Even at the political level, people realize that we need to address all of those topics at the same time. So for 15 years, there is a better awareness. We've made great progress. It was too slow, but we are making progress. Thank you, Yves, for this introduction. It's very thorough and very clear at the same time. Three messages. The emergence of this environmental health concept and One Health more broadly. The second topic, the importance of analytical progress. Without analytics, we wouldn't be there today. We wouldn't be here today. And then there's a clear awareness of the problem. My first question, you went a bit quickly on the topic of exposome. If I understood correctly, exposome is the total of environmental exposures. So a layman and complex question at the same time. We are exposed to multiple, wide diversity of substances before we're born and after. So how can we address or approach this concept of multiple exposure to chemical compounds? This is a very important notion. It's extremely important because we tend to put it in line with genomics. We heard about it a few years ago. A few years ago, we discovered human genome. It was exceptional. We said, thanks to this, we're going to be able to cure all illnesses. It's going to be fantastic. So we invested a lot in genomics. We set up genopoles. There was a lot of global research on this topic. The exposome, however, in my opinion and in the opinion of other experts, is at the same level. So it's important to be able to measure all the exposures throughout our life so as to list it in a big computer, and we have great computers nowadays, and we can also put on the side all our knowledge about diseases. So if we can list all of this and put everything in a big modeling machine, and it is the objective, well, you can say, you were born in this city, you were raised here, you work in this industry, you eat this, you do that, you exercise this much, etc. You input all this information and you end up with one conclusion regarding the health risks. So this is done at the individual level, but if you do it at the population level, you are able to identify all the major risk sources, and that way you can work on prevention. The objective, very essentially, is to know all of our exposures, the ones here in this room today that we might not be familiar with, but there are great sensors to do it, and we can multiply it with what we breathe in the RER, in the train, on the metro, etc. And then you can identify the major spots that interfere on our health, and that way you can cut risks and globally improve our health. There was great progress. There are European programs funded, about 100 million euros. In my opinion, it is still too little, too small, too slow. But over the past 10 to 15 years, we've made great progress, and this is starting to improve. And at the national level, there should be an expology or exposure measurement institute, or even at the European level. In my opinion, this is a great source of progress for the future. Thank you. Back to mixes or mixtures. We, in the media or in the literature, we are talking about micropollutants or emerging pollutants. So you talked about different families. You've talked about endocrine disruptors, microplastics, phthalates, etc. So can you tell us more about a specific family of chemical hazard mixtures, for example, the PFAS, and tell us what we know and what we don't know, because sometimes there are things we don't know. Tell us more about the exposures modalities and the risks coming from the PFAS. Absolutely. So it is an example. We talk about it a lot nowadays for a specific reason. Europe might ban these compounds. So in several countries, but I'm thinking about Germany more specifically, about 15, 20 years ago, they started discovering those water polluting molecules, and then they went up the cycle. They did some studies on the people who were contaminated, and so scientists for the past 20 years have known that those are hazardous compounds. And as you saw how long it took before the regulatory authorities decided to potentially ban them. So at the Technology Academy, we are going to set up a working group to start thinking about the impact on the industries, so industries that use those compounds and the industries that need to remove them. So this is going to have a huge economic impact. This is led by the Health Ministry and the Medicine Academy. They are going to be involved to talk about the health hazards. So what are those compounds? It's very simple. One day we told the chemist, could you build in your lab a compound that could be waterproof and that is not washed away when it rains. You know, if it rains on your umbrella and the following day the umbrella is no longer waterproof, it's useless. So the chemists did their work. They did their work with their little tubes, etc. And they found something fantastic. Just like the PCB in electric generators. So you find these compounds, they are good to waterproof everything. They are everywhere. You can use them inside batteries, and you know the battery industry nowadays is extremely important. You find it also in food products, in cosmetics, and those compounds are very, very interesting, but they are indestructible. Well, indestructible with our conventional practices or methods, and they accumulate in fat as well, and therefore they completely invaded the planet because you can't get rid of them in water treatment plants. In nature, they are not biodegradable, and they accumulate in fat. And so in the food chain, there were more and more of those compounds. And now we realize that they have an impact on our health. They have an impact on our hormones. They have different toxic actions in the body. And so you realize that how this problem should be managed at the global level. You know, it's we find these compounds in the fat of animals that never across the city. So the whole industry needs to be transformed. These compounds need to be transformed or changed. And the alternatives are not great. And we also need to think about how we can decontaminate. For PCB, it was very difficult because there are a lot of PCBs in rivers. One day a politician said we all need to decontaminate rivers. Well, that's very kind, but it's a bit complicated to decontaminate the Rhone River. It's not easy. So this family of compounds is an example of other families of compounds which are greatly useful. They helped us improve our life expectancies, just like plastics. You know, thanks to plastics, we were able to do a lot of things. But the problem is that now they are everywhere, without borders, without any limits, with an impact on animals and on people. Well, this sort of make us think about why we or how we should market those compounds. Some compounds are very interesting, but they also have a huge environmental impact. So let's be wary of people who all of a sudden are saying, oh, we have to get rid of all of this. And we tend to forget about pesticides as well. And, you know, we focus on drugs, we forget about pesticide, then we focus on endocrine disruptor, which is rightly so. But there are many different compounds that impact our hormones. So we stop talking about drug residues. And then we talk about PFAS, and we convene a big meeting with a lot of experts. But our problem, your problem as professionals and as people, as citizens, our problem is that we are exposed to all of those compounds. And this is when we talk to the toxicologist and we ask them, which compound should we focus on first? We won't be able to address all of them at the same time. So it's important to be wary of the media waves. Because it's based on logic, but at the same time, if you focus on one product, you tend to overlook the other ones. And we need to have a global approach, which is a challenge. Thank you for your answer. Back to your slides. Once we've identified an exposure thanks to analytics. We need to move on to the second step, risk analysis. So nowadays, how do we do that? And who's in charge of this risk assessment in France, namely? And how does France fare compared to other countries in Europe and in the rest of the world? How do we assess those risks? Well, yeah, it's a logical next step. The chemist, analytics experts input the sample or put the sample in the fantastic machine and comes up with a whole list of compounds. But they'll never say whether the compounds are hazardous or not. That's not their job. Well, we can't blame them for that. So who are we going to turn to? We're going to turn to a toxicologist. The toxicologist is going to extract pollutants from grapes, from water, air, and they're going to feed them to animals, to cells in a petri dish, and after 3 to 5 years, they'll say, oh, this is genotoxic, this has an impact on our genes, it is a disruptor for the heart functions, etc. So they characterize the impact of those compounds or of a mixture. It doesn't really mean that it's a risk. If a compound is only or only exists in a faraway country and it's not in France, there's no exposure and therefore there is no risk. The risk will materialize in the faraway country, but not here. So it's important to characterize the risk. And who's in charge of doing that? Health organizations, health agencies. So in major countries, I'm not going to say developed countries, but economically developed countries, in those countries you have organizations that take all this information and they are going to look at pregnant women, young children, adults, and they'll say, okay, an adult eats 30 kilos of this food, drinks this many liters of this water. Knowing the risk of the molecule compound, they multiply everything. They add an uncertainty factor because it's never very precise. So you add a protection factor and you end up with a limit value, a regulatory limit to set up norms to protect health. And usually we take the largest impact and the most vulnerable individual. So sometimes a norm is based on a young child, a baby, because we know that they will be the most vulnerable to this contaminant. And since we want to protect the whole population, we're going to focus on that.
In France, we have the National Agency for Public Health. They're experts in toxicology, and they come together and they carry out this work. Sometimes it takes a long time. And of course, there are equivalent agencies in Germany and the Netherlands and elsewhere. Everyone participates. Some people think it's some sort of a French plot. But no. There are expert committees that are international, that exchange information and work together. And if one country discovers something, all of the other countries are informed immediately. So it is really a scientific work that is carried out internationally. And then there's management. If we don't have toxicological data, then what do we do? Perhaps you're looking all through scientific literature, you're questioning experts, and they don't have information about a given molecule. Then, taxpayers and citizens, as we all are, might say, in the fruits that I bought or in my glass of water, there are these pollutant chemicals. And the experts might answer, we don't have the information about the toxicity of this chemical, this molecule. And then the experts will try to come up with a standard for management. This is not scientific. This is based on a sufficient level of protection. And we calculate this value, and this is a standard that enables us to protect the population. It's not that easy because you have to have experts, you have to have data, you have to have a little bit of distance and some experience in order to reach a consensus so that you can set forward this standard. And you mustn't mistake policymakers and experts who are evaluating the risk. Each has a job to do. One looks at the evidence and the other makes decisions. You said that it can still be difficult today to evaluate environmental health risks. So there are a lot of uncertainties, in fact, around the levels of risk. How can we really integrate public health authorities and into this paradigm. And if we look back a few months or years and look at the COVID crisis, we could see that a lot of citizens were suspicious of scientific expertise. What would you say about those 2 points? Well, it's true that today, not only decision makers but citizens are having a hard time renewing their confidence in the people who are here to protect our public health. You've seen that in France today. We consider that professors in schools and others with knowledge are sometimes not given a high level of consideration. Teachers and professors used to be highly considered in society. They were people that had knowledge and that shared that knowledge with the children who were therefore able to develop in life and develop skills and knowledge. And now we see these teachers is going so far as the teachers are being killed in their classrooms. Now, the COVID crisis, it's true, there were all sorts of experts on the TV saying this, that, and the other. And, you know, a journalist would introduce someone as an expert in the questions of viruses, and perhaps they were introducing someone who was just a GP. But because the media needed a lot of quotes and because the social networks wanted a lot of content, all sorts of people were making declarations, and they were not necessarily the people with the knowledge to protect public health. Now, when we're looking at a sample and we see 50 different pollutants in it, maybe out of the 50, we don't have information on 40 of them. Well, then the expert could be criticized. People might say, well, you don't know anything about it. And we'll say, no, it's that no one has any information about a certain number of these pollutants. The means at the disposal of scientists and experts are rather limited. And sometimes decisions have to be made quickly, and we can't wait 10 years for the toxicologist to carry out all the necessary studies. So this means that the public, the general public, has to admit that there are situations where science, worldwide science, does not have all the answers immediately. So I can't give you a specific value. The value might be in a range of values, in fact, because that's what we can do best at a given time. But it does help us to protect ourselves. But people don't readily admit this. Now, there's the question of grapes, for example. I mentioned fruit earlier. Grapes are often have a lot of pesticides and pollutant substances on them. Now, if people say, I don't want any pesticides on the grapes that I buy at the store, well, it's going to be impossible because the pesticides are everywhere. So people have to understand that studies have enabled us to see that although there is a lot of imprecision, we only allow things that have a certain level of safety on the market. It's also a problem of education in the schools. In French schools, there are no courses on health. There's physiology, you learn how your organs work, what your body is, what water is for, but at the same time, we don't have a course on health. Each child who is coming out of secondary school should understand questions about how he can manage his or her health, including environmental health issues. And this would help reestablish confidence in experts. It's very complicated. We saw this during COVID. The President of the Republic went into the offices of a great virologist, and it seemed that a lot of what he was saying was not verifiable, and people lost confidence. And it became something that wasn't a scientific debate, but it was more of a personal debate about who do you trust and who don't you trust. So you've talked about a lot of different stakeholders and actors from the education system, citizens, authorities. What about the industrial stakeholders? For you, for a group like Veolia, for example, what should be our role in environmental health more broadly? That's a good question, and it's a subject that's close to my heart because I spent part of my career in private research centers, and so I've worked in the university and also in the private sector, so public and private. And I've always seen that when intelligent people from the two sectors, public and private, get together, then we'd get really good work done. So sometimes the public thinks that if it's a private research center, there will be conflict of interest, and that's often true. And some people think that everything that comes from the public sector is too constraining, that the people are incompetent. So we have to stop this dichotomy. You have to get smart people from both sides, get them to work together on these important questions. And the question we're talking about today, which is multi-chemical contamination that has an impact on public health, is a fundamental issue. We're not going to prohibit all plastics tomorrow, but at some time we will have to find alternatives to all of this plastic material in our environment. So we need to work with the plastics industry and with public health authorities to go as quickly as possible on this issue. At Veolia, you work on depolluting, which is extraordinary because people, I think, don't know enough about this. People hear people talk about Veolia when they get their water bill, but they don't know what Veolia is doing to treat and clean water. Remember, at the beginning in the city of Le Havre, there was the Municipal Water Bureau that wanted to take in hand everything that had to do with protecting the population from water contaminants, and all of the actions that you carry out in the area of environmental health. These actions are not well enough known, in my opinion. And the authorities have recognized this, that there are some things that the authorities cannot do without the help of industry. And on the other hand, we also have in the public sector and public research in particular, we need to work with industry, because when we see the means that are put to environmental health research in France or in Europe in general, we can see that it's quite disproportionate. You at Veolia have knowledge of the field that laboratory researchers don't necessarily have. You have means that are quite disproportionate when compared to public health laboratories. So the question today clearly is, how can we have good collaboration between the many activities of your group and other actors in the environmental health sector? And this could be a constructive partnership with public health authorities. And this happens every time there's a crisis in any event. We have waste management, water management authorities working with industrial actors. It happens every time there's a crisis. And this partnership should become something that is more natural, more constructive, and the public should be made more aware of it, so that they can see that public and private actors have taken on board these questions of environmental health, and they're concerned about our health, about their grandchildren's health. And there shouldn't be a separation between public and private. I think each of you in your activities here in Veolia, you are necessarily associated either as a potential polluter, when you have an incinerator burning household waste, for example, or you are a potential factor for depolluting things. So you can provide information and help to policymakers. Thank you. There are a lot of other questions I'd like to ask, but time is going by. And before I give the microphone to the floor, I would like to ask you one more question. In fact, it's a double-barreled question. For you, what are the main challenges for tomorrow in terms of progress in reducing chemical risks and depollution? And more broadly, what are the main challenges regarding environmental health? It's a difficult question, but maybe you could give a brief brief answer so we could open the floor to questions. Well, it's not that difficult to answer the question, but it's difficult to put the answer into action. We have to target things because we can't do everything. We have to identify the major targets for action. When we look at the overall problems, where can we act to have a significant impact on improving environmental health? This means we have to develop knowledge, measurements, data. Once we have data, then we can sit around and we can sit around the table together with all the different stakeholders and identify our priorities. And then policymakers can make their enlightened decisions, and then we can provide the necessary budgetary means. And of course, it's also important to be quite transparent with citizens, to explain to them what needs to be done. I'm thinking about Switzerland, for example. They were looking at medical residue and pesticides, and they decided they didn't want these residues present anymore, and so they levied a tax, and this tax enabled the processing of water to remove these undesirable elements. In Switzerland, the environment is very important to them, in France as well. And once you give a clear explanation to citizens, I think they're usually willing to contribute. At least I would hope so. Thank you very much for your presentation and for answering our questions. We have talked about uncertainties, about the main chemical pollutant risks. And now I'd like to suggest that we give the floor to the people here with us in the auditorium today. The first question is always the hardest. Do laws and regulations talk about exposum? No. This word is included in some texts, including in the new law on environmental health and safety. But you know that in France and in many other countries, there is a national plan. You know, of course, there are lots of national plans. Whenever there's a problem, there's a plan. But what's important is to see how much money is behind the plan. That's how you know if it will be effective or not. And there is a national plan for environmental health, and it does talk about exposum. But the notion is still associated with research today. The notion of exposum is something that we think about when we look towards the future. But in fact, we already do have very big databases with parameters for measurement, and we do have a lot of information. I don't think that we will have regulations where it will specifically speak about exposome. But we do have, on the European level, the REACH program, which examines chemical products before they are brought to market. And this should enable us to keep the most dangerous chemical products off the market. And recently I heard that the REACH program was wavering a bit, and that it was hard to make these medium-term policy decisions. So I think today this is something that we need to develop in our research programs. Hello? You talked about REACH, and as a citizen, I'm a bit shocked by the fact that in this example, when we're looking at the development of molecules, and a scientist develops a molecule and wants to put it on the market, and in fact, there are molecules on the market that we don't know much about, and we might learn 10 years later that the molecule is dangerous, whereas it's been in use for 10 years. I wonder about the principle of precaution. This has been in the Constitution for some 20 years now. So how can you reconcile this with the idea that some molecules are put on the market, whereas we don't know much about them? The principle of precaution is something that we discuss quite a bit, and a lot of times people talk about it without really understanding what it is. In policymaking decisions, people either are for or against. Some people are shouting this is scandalous, and other people are saying, no, we need this, we need to apply it everywhere, and they don't have the same vision. And I want to come back to the basics, which is the principle of precaution was attached to environmental concerns, and the Academy of Medicine recently talked about the principle of precaution in medicine, because if a doctor has to make a decision in his office or her office, sometimes the decision is made without all of the data that would be required, and so the principle of precaution must be applied. Suppose your child is in school and suddenly half of the class falls into a faint. You don't know why. You're not going to wait for the results of a study. The principal will have everyone leave the school building immediately. This is a precautionary step. And this should be applied to all types of decisions. It seems quite logical. If the principal of the school said, oh no, we'll just leave those kids on the ground and then we'll come in and we'll measure the air and we'll measure the food, and that would be terrible. You would think that principal had made a bad decision. So when we're looking at questions of health and we don't have enough data, you have to take precautions. That's normal. And that is why REACH regulations were set up in Europe. That is, that we don't put molecules on the market without having carried out evaluations of their risks. This is not so much precaution as it is prevention. This is the principle of prevention, which is I know what the danger is, I know what the effects are, and so to prevent problems, I will block market access. Unfortunately, as I was saying earlier, REACH, which was supposed to allow all member states to look at all the different molecules, it's rather complicated. It takes some time and money. But so REACH is quite slow moving. And so we are stuck with the same problem, which is the necessary time. And meanwhile, the molecule has reached the market, and in particular, molecules that were developed in the past. We have the same question with medicines that are put on the market. That sometimes the study may take up to 10 years before a medicine can be released. We had the problem with asbestos. And over time, we were able to discover the impacts of asbestos on health and then to remove it. So there is a whole logical process that has taken place historically. And nowadays, people are much more demanding with regard to identifying dangerous products. And sometimes it seems quite slow moving because we don't have the means to go forward as quickly as we would like with all the new molecules that are coming around. It's important to explain to people in this notion of confidence that I mentioned earlier that we will have to change our lifestyles, even in our homes. Look at all the chemical products you have in your home, whether it's incense or perfumed scented candles or air fresheners. You have all this in your home. And you might ask yourself the question, is this a problem for my health? So prevention and precaution, I think if you should maybe get rid of 2/3 of all of these chemical products that you already have in your home. It would be better for your children's health. But I think people aren't necessarily ready to accept that. They don't really understand that. People like to have these air fresheners in their toilets. You have guests coming and you'd rather have something smelling fresh, but you could at the same time, this could be detrimental to the health of your family. So it's really important that we have a deep-seated work of explanation and communication with the public. That's why I was saying it's important that we start teaching people in school. Here we have a question online. Could we share Veolia's online data collection resources with the public authorities? Not only could we, but we should. Of course, after that, it depends on the company. Here's another example, not Veolia, but when we're looking at medical residues in the environment, there was a national plan, once again, a national plan for medical residues. And experts said we need the data on the sales of medicines for each watershed area. This does exist, but you have to buy it, and it's very expensive for research laboratories to buy this data. So the national plan decided that the ministries should be able to request this data from industry so that all of the labs could have access to it. And now many years have gone by and we still don't have this data. Now, I think we're often dependent on the goodwill of industries that are producing medicines or selling them. And we would need better collaboration so that we can study exposure. It would be good for business, and it would be good for the government, and it would be good for public health in general if there was more collaboration. Since when and how have we studied the interaction between different molecules? You showed a slide with different molecules, and you said that there were mixtures and interactions. How are these interactions now taken into account? In studies, for example, in my lab, we take a sample of water, drinking water or wastewater, but it would be the same thing for food. We don't need to focus on water only, but that's my specialty. And we would take the molecules out of the water with our means. We know that we don't catch everything, but when a lab says, I extracted all the pollutants, that's not true. They will only have extracted some of them. So we take this mixture. Say you have 10 liters of water, and you concentrate it into just a few milliliters. Will it be exactly equivalent? We don't know exactly. Then we put it in contact with different cells with special models, or we have it absorbed by animals, and then we can see what the effects of the mixture is. And we say, why did the animal develop a cancer? We don't know, because it's a complex mixture, so we don't know exactly which molecule triggered it. So we look at the mixture, and then we break it down into sub-fractional units, and we test each one until we can find what was really responsible for causing the cancer, for example. This is something that takes place in a laboratory, but it's not routine. We don't do these mixture tests routinely. There are a few software programs that can predict the toxic effect of specific mixtures, but it is impossible to have a generalized approach to these mixtures because each mixture is going to be different. But we are making progress. And in the medium term, I think that European regulations will be taking into account bioassays. That is, they will be taking samples, mixing it with cells A, B, C, etc. Specialists know how to do this, and then they will give names to these mixtures. So for crustacean, for example, we'll see if it reacts in this way or that way. This is unacceptable. So today, the standards are lists of products with values. These bioassays are not yet included in regulations, but there are good signs because the EU Commission is financing studies to try to identify these bioassays. It's not easy. When you buy a measurement device, you calibrate them, but then if you've got mammal cells, fish, mice, it's not easy. That's why I'm talking about medium term, but we are moving forward. We should be positive about this. Thank you very much. That was very clear. It was quite enlightening. You were talking about health education for children. Do you have examples of countries in Europe? Earlier you mentioned Switzerland, countries in Europe that may have begun recently or for a long time to set up health education programs. And then another example, the United States. The United States is a big market. There's a powerful FDA agency. There are a lot of lobbies as well. There's a lot of media pressure. There are a lot of films made on these subjects. Does the FDA or does the United States in general take a better account of some of these issues that you've brought up today? With regard to schools, we have done a lot of work over the past year at the Academy of Medicine on this subject, and we have suggested to authorities that we should introduce the topic of health in school. But of course, lots of people would like to introduce lots of different topics at school. Some people want more time spent on mathematics or other topics, and schools are quite submerged with this type of demand. But we do need to introduce information, perhaps in some of the existing courses. I think that in Europe, there are not many countries that have health education programs in their schools. In Japan, however, in each school, there is one person who's in charge of giving a health class. And that person is an employee of the school. Sometimes that person could also be a nurse and in charge of giving this course. And that's quite interesting, but that is has been part of Japanese education for a long time. Today, there are people who come in and talk about tobacco addiction or sexual health, but they're one-off. And it depends a lot on the region or on the principal of the school. That doesn't mean that there's nothing on health in the schools, but we don't have a structured response. A citizen who's leaving school should know how to read, write, count, behave in society. And what else? They should know French, and they should know how to protect their health. That is, health is really the basic thing that we all share, and you understand when you're sick, you would like to be well.
So this is essential for citizens. It is essential to be good at math and to be good at health. But before it changes in some policymakers' mindsets, well, time will have come by. But when we talk about it individually, they say, yeah, it's important. In the US, people are very aware of these issues. More specifically about water, but it's relevant for other topics. They've always had this approach where they identify toxic substance per toxic systems. They're not doing much more in terms of mixtures than in Europe, and there is a scientific concern. There are American resources which are beyond ours. So we are roughly at the same level. It was not the case 30 years ago. Now, I might sound old, but back in the days, France was really lagging behind compared to the Anglo-Saxons, the German, the Dutch, when it comes to the relationship between environment and health. We caught up, so that's for sure. This is why I insisted on the fact that this scientific knowledge is global. And it is advancing very slowly, unfortunately, but it is advancing and moving forward collectively. Thank you for your answers. Unfortunately, I think this is all the time we had. I'm sure there were many other questions. If there are more questions, we will send them to Professor Lévi and you'll give us your answers. Before giving the floor to Dina for a conclusion, I think that, well, we'll continue talking at the cocktail. So I now give the floor to Dina for a conclusion. Nothing to say on my side. I just wanted to thank you very much for this information. It really broadened our horizons. I'm sure that we're going to dig deeper into the topics. As an institute, we are going to dig deeper, and we'll get back to you to talk about various topics, methodology, where we made progress, what's still to come, what still needs to be done. So once again, I wanted to thank you, especially you, Professor, for coming. I would also like to thank you for attending and asking questions. questions. And as a reminder, you can continue the conversation with a snack and a cocktail upstairs. And, well, you'll tell us, so we are going to send you a satisfaction survey. You'll tell us if this was enlightening, if there are other topics that you would like to know more about. We thought about antibiotics resistance, for example, but there are other ideas. So all your suggestions are welcome. Thank you very much. Thank you for your attention, and thank you to the interpreters. Thank you.